conduit can be installed in the knockouts of an extension box. The National Electrical Code, specifically Section 314.23a, addresses the use of conduit bodies equipped with threaded hubs. This section states that conduit bodies equipped with threaded hubs shall be permitted to be installed with conduit or nipples connected to the hubs. This means if the extension box or conduit body has threaded hubs, you can directly thread conduit or nipples into those hubs. Section 314.23d provides guidance for conduit bodies not equipped with threaded hubs. It states that conduit bodies not equipped with threaded hubs shall be permitted to have conduit or nipples attached to the conduit bodies by means of a bonding jumper meeting the requirements of 250.102. In cases where the extension box or conduit body does not have threaded hubs, you can still attach conduit or nipples. However, you must use a bonding jumper that meets the requirements of Section 250.102 to ensure proper electrical continuity and grounding. Firstly, the conduit size must be appropriate for the size of the knockouts. Don't try to force a larger conduit into a smaller knockout, as this could damage the box and create an unsafe installation. Secondly, the conduit must be securely connected to the knockouts using lock nuts or other approved methods. This will ensure a reliable electrical connection and prevent the conduit from coming loose. Thirdly, the number of conduits that can be installed in the knockouts must not exceed the allowable fill space. Overfilling the box can lead to overheating and other problems. You should always consult the National Electrical Code and local regulations for specific requirements and restrictions related to conduit installations in electrical boxes. Always ensure that all electrical work is performed by a qualified electrician who is familiar with the National Electrical Code and local regulations. When installing conduit in extension box knockouts, consider several factors to ensure a safe and code-compliant installation. The selection of the correct conduit size is paramount. Always match the conduit size to the knockout size to prevent stress in the box and ensure a secure connection. Exceeding the knockout size can lead to instability and potential hazards. Proper securement is also vital. Lock nuts, bushings, and other approved fittings must be used to firmly attach the conduit to the knockout. This prevents the conduit from dislodging due to vibration, physical stress, or thermal expansion. The fill capacity of the extension box is another critical consideration. The number and size of conductors within the conduit must not exceed the box's fill capacity as specified in the National Electrical Code. Overfilling can lead to overheating and insulation damage. Grounding and bonding are essential for safety. Ensure that the conduit system is properly grounded and bonded according to the National Electrical Code requirements, especially when using non-metallic conduit or fittings. This minimizes the risk of electrical shock and ensures proper fault current flow. When referring to Section 250.102, focus on the specifics of equipment bonding jumpers. These jumpers are used to connect metallic parts of electrical equipment to the grounding system, providing a low impedance path for fault current. The size of the bonding jumper is determined by the size of the ungrounded conductors supplying the equipment. The National Electrical Code provides tables and guidelines for selecting the appropriate bonding jumper size. The installation of conduit in extension box knockouts requires a thorough understanding of electrical codes, proper techniques, and attention to safety. Consulting with a qualified electrician and adhering to the National Electrical Code guidelines is always recommended. Furthermore, you must also ensure that the extension box is adequately supported. Use appropriate mounting hardware to securely attach the box to a structural element. The support must be able to withstand the weight of the box, the conduit, and any attached equipment. Prior to commencing any work, you must verify that the power is disconnected to the circuit. Use a reliable voltage tester to confirm that the circuit is de-energized before handling any wires or components. Lockout-tagout procedures should always be followed to prevent accidental re-energization of the circuit while work is in progress. Additionally, you must ensure all conductors are properly insulated. Inspect the insulation of all wires for any signs of damage, such as cuts, abrasions, or cracking. Replace any wires with damaged insulation to prevent short circuits or electrical shocks. Always use appropriately rated tools and equipment for the task. Using the wrong tools can damage the equipment or create unsafe conditions. For example, use conduit benders designed for the specific type and size of conduit being installed. Finally, remember to thoroughly inspect your work. Once the installation is complete, carefully inspect all connections, ports, and grounding to ensure that they are secure and in compliance with the National Electrical Code. Perform a continuity test to verify that the grounding system is properly connected. By adhering to these additional considerations, you can ensure a safe, reliable, and code-compliant installation of conduit and extension box knockouts. You can also consider the environment to decide what type of conduit you need to run. For example, if you are in an area that has a lot of moisture, you should use liquid-tight conduit. Consider the environment for your wire as well. THHN and THWN are common wire types and are rated for dry and wet locations respectively. It is always important to check with your local guidelines, as the National Electrical Code is used as a baseline code, and your local area may have stricter rules or guidelines that you must abide by. Always use the newest codebook and stay up to date on changes that occur, as that is your guide to do the job safely and correctly. It is your responsibility to be up to date on current code and to ensure your work is correct. Failing to follow these guidelines or best practices may have serious effects on you and the people around you. Always take the time to read and follow the proper guidelines. Take, for example, running conduit through different types of buildings. The types of buildings would affect the conduit you run, as one building may be a highly corrosive environment which would require a special conduit coating to keep the conduit from rusting. Another consideration to keep in mind is working in tight spaces. If you are in a small, tight or confined space, you may need to use more pulling points for your wire. This would involve adding more junction boxes or pull boxes to make it easier to pull the wire through the conduit. Also, when bending conduit, you need to make sure that the bends do not exceed the amount specified in the NEC. The code requires that the total bend between pull points do not exceed 360 degrees. This is to ensure that you are able to pull the wire safely and correctly. There are certain boxes that are rated for certain applications as well. For example, you can have a box that is rated to be submerged underwater. Another box example may be a fire-rated box to withstand high temperatures for a certain amount of time. These examples are just a few of the types of boxes that are available to use. Make sure to check the rating on the box before you install it to verify that it is indeed rated for your application. You can also use different types of fittings for different applications as well. Some fittings are liquid tight and some are not. It is best to figure out what your application is before you begin your project to ensure that you are using the correct parts. Using the wrong parts can lead to future problems. When dealing with electricity, it is always best to have everything be properly rated and installed. The cost of doing the job right the first time will outweigh the cost of having to go back and fix an improper installation. An improper installation can also be dangerous, as it can cause a fire or electrocution. So to be sure, always be sure to refer to your code book and make sure that everything you do is to code. If you aren't sure, then ask an electrician who is qualified and knows the current code.